Okay, so first off, determine the equation of both factor form and standard form that best represents the graph shown. So step 1, identify the vertex. What's my vertex here? Take a look at the graph. Len? Okay, so Len says 3, -1. Who has a different vertex? Yeah. 3, -4. Where did that -4 come from? Why is it 3, -4? Yeah?
Because the y-axis, it goes up and eats. Like 1 square is a 4.
Yeah. So you have to pay attention to the scale. So yes, that was a tricky question. So don't assume every box is 1, especially when you're given a graph and you have to come up with the equation. So yeah, every box is actually 4. So in this case, this is -4 right here. So 3, -4. We're going to plug it into this formula, which we just found out. X minus 3 square plus minus 4. Right? We just plugged in the h and the k in these vertex form equation. Okay, and then step 3, I'm going to find a by substituting any one of the points into the equation. So looking at this graph right here, which point looks like a nice and neat graph, a nice and neat point to plug in? Yep. 2, 0. Good. Okay, this point looks like it's a nice, easy point to sub in. So I'm going to sub in 2, 0 in the equation. So this is your x, this is your y. So 0 equal a 2 minus 3 square minus 4. So 0 equals a -1 square minus 4. Okay, -1 square is just 1. So you have 0 equals a minus 4. When you move that 4 over, a is 4. Now looking at this graph, does it make sense that a is 4? Yeah, it opens upwards, it's positive. It's over 1, up 4, over 1, up 12, over 1, up so forth. Yep.
Is there a reason why you don't substitute for vertex?
Sorry, say that again?
Is there a reason why you don't substitute for vertex?
Oh, because I already substituted the vertex to make this equation.
But you can't use that again.
Yeah, otherwise I'll get 0.
Okay.
Yeah.
So it has to be any point besides.
Yeah. Okay. Tomorrow. Tomorrow, if we set up the equation a different method, then we can sub in the vertex. So tomorrow. Yeah, you're always looking ahead. Okay, so now that we know what a is, we can state our final equation. What is my final equation then? Y equal? Yep.
Y equals 4 bracket x minus 3 squared and minus.
Perfect. Okay, so all I did different was substitute the a in my step number 2. I replaced the a in step number 2. Now I have this equation. Okay. Step 5, expand to standard form, which is what we did last chapter. Okay. So y equal. So remember on the test, some people still made this mistake. Okay, x minus 3 squared is not x squared minus 9. It's x minus 3 times x minus 3. So some people made that mistake on the last test. Make sure you don't make that same mistake on this test. So y equals 4 bracket, do FOIL. When you do FOIL, you'll realize that you have a middle term, x squared minus 6x plus 9. All right, x squared minus 3x, and then plus 9. Okay, now I can distribute that 4 into everything inside this bracket by multiplying. So y equals 4x squared minus 24x plus 36 minus 4. So my final equation in standard form, y equal 4x squared minus 24x plus 32. Okay? Take a look at this equation in standard form and take a look at your parabola, the graph right here. What do you notice? What do you notice with this equation and the graph that's given? Okay, I'll put it side by side so it's a little easier for you guys to see. Okay. So in standard form, what do you notice? What connection do you see from here and here? Any wild guesses? Connection between the equation and this graph right here. Anything in particular stands out? Yeah? The y-intercept. What is your y-intercept right here? 32. 32. Okay. So that's why we have different forms. Standard form tells you the y-intercept. So standard form tells you y-intercept. What do you think vertex form tells you? The vertex. Whoa, how did you know that, Jintao? Yeah. And vertex form tells you vertex. Right? And then tomorrow, we're going to learn the third form.
So the constant in standard form will always be the y-intercept?
Yes. Okay. How's example 1? Understandable? All good? Okay. So that's why I'm combining like today's lesson and like together because this is a short lesson. Okay, so example 2, while on vacation, Steve had nothing else to do on his vacation but to film a cliff diver. After filming it, he decided to analyze that video and record the time and height of the diver in the table below. Okay, determine an algebraic model to fit the data. So algebraic model, aka equation. Okay, so for this right here, should I do a L graph or a T graph? What type of graph should I do? How do I draw my axis? Should I draw a T or should I do a L? What do you think? Yeah? What doesn't have negative? More specifically, why can't I have negative values? Okay, yeah. In terms of this word problem, what does my x-axis represent? Time. So can you have negative time? No. So that's why in this case, yeah, L graph is sufficient. We just put time. Time starts at 0, and then this would be our height. Okay, M. So time, looking at the table right here, I see I just need to go from 0 to 2. So I'm going to do like 1, 2, 3, 4, something like that. Okay, spread it out. Spread out the graph. So every 4 box is 1. And then for my height right here, okay, 35 is the highest I'll need to go. So 5, 10, 15, 20, 25, 30, 35. Okay, plot the points. 0.35, 0.5, and 33.75. 33.75. 1 and 30. 1.5 and 23.75. And then 2 and 15. Okay. How should I connect these dots? Yep. A curve, right? So no line, curve. Okay. You guys make me so proud of my line of my curves. Okay. So now I have this curve using what we learned in example 1. Can we come up with our equation? Okay, so standard equation, y equal ax minus h squared plus k. What's my vertex in this case? Yep. 0.35 is your highest point. So that diver is at their highest point, 0.35. So sub that in. Sub 0.35 for HK. So y equal a x minus 0 squared plus 35. Okay. What is x minus 0? Kelly? Just x. Yeah, so my equation is just y equal ax squared plus 35. Alright, and it makes sense because my vertex is on my x-axis. I'm not shifting left, I'm not shifting right. That's why there's no bracket. Okay. Next, Ryan, what point should I plug in now into this equation?
Like let's say
1 and 30, yeah. Any other point but the vertex. So this point, let's say. So I'm gonna sub 1 and 30 for xy. Okay. So 30 equal a 1 square plus 35. Okay. 1 square is just 1. 1 times a is just a. So 30 equal a plus 35. Move the 35 over. By subtracting, I get a is negative 5. Okay. And every time I get the a value, I take a look at my graph to see if it makes sense. My parabola is opening down. My a is negative. That makes sense. Over 1, down 5. That makes sense. Okay, so yeah, seems like I have the right a value. So what is my final equation then? So therefore, the parabola has the equation y equal. Yep.
Or just x squared.
Yeah.
Plus 35.
Okay.
It was instant.
Yes. Okay. So this is an equation of a parabola, but I don't see a parabola right here. It's a half of a parabola. So technically, I do have the other side of the parabola this way. Because I can't have negative time, that's why we use this. So technically, when you get integrated 11, you can add in here x greater or equal to 0. Okay, so for now, if you just give this, that's perfect. But when you get into grade 11, you'll have to say something like this as well, because this is only valid if x is greater than 0. If it's less than 0, doesn't make sense.
For a question like this, like for word problems, where it gave you like s and m for instead of x and y, would it be better to write the equation using like s and m, or can we just write it with x and y?
Doesn't matter. I'm good with either or. Yeah. Okay, and then last part. When will the diver be 5 meters above the water? So where should I sub in this 5? Kelly?
Because 5 is like the y bar. Yeah, it's the y bar. So you submit the y bar.
Yes, this is height.
Yeah.
Remember, your x was the time, your y was the height. Since this is a height, that means y equals 5. I'm going to substitute y equals 5 in here. So substitute y equals 5 in here. Okay. So solve for x. We did that in the last chapter. So solving for this, move this over. So 5 minus 35 gives us negative 30. Divide by that by negative 5, I get 6. Okay, and then square root. Square root of x. Square root of 6. Square root 6, what do I get? About 2.5. So x is about 2.5. What's my unit? Yep, seconds. Good. So therefore, the diver should reach a height of 5 meters after about 2.5 seconds. And if we continue our parabola, it looks about right. Okay, so he dives, and then after about 2.5 seconds, he gets to 5 meters. Okay, so a lot of these you could verify with the graph. Remember, your answer should match up with the graph because it's the same parabola. Okay, so that was a quick 15-minute lesson. Here's some practice questions and homework questions. Any question on today's what we did today? We did 2 and 1 today.
Wait, do you know what the next test is?
Yes, I do. Your next test is actually written right on Bryce's face. If you go to home,
This Friday?
this Friday. Yeah.
Only transformation.
Yeah.
Not the agent.
This is part of,
Is it transformation book?
yeah. This is the same chapter. So if you take a look at content, chapter 5 right here.
Okay.
Yeah. So today we did vertex form. Tomorrow, Tuesday, we'll do factor form. And then Wednesday, Thursday is review. And that's it. So we just have one more lesson tomorrow. And then we're done. Yeah, so not too bad. So, and I think you guys understood everything very well in this chapter. Okay. So do practice these ones. That's your homework tonight. So not a lot, just these. Just to get you guys to practice coming up with the equation given a graph. All right.